Okay, example number 4. This is 9.2 part 1. It says find the standard form equation for a hyperbola with vertices at 0, 6 and 0, negative 6. So what would be in the middle of these two would be 0, 0. So we know our center is at 0, 0. And then if they're going from 0, 6 to 0, negative 6, then the y values are changing. So that tells us that this is going to be a vertical asymptote. It also tells us that it's going to be, not that, in this form, with the y squared first, since the y value is changing for the vertices. So it's going to be y squared over a squared. Remember, a is always first for hyperbolas, so y squared over a squared minus x squared over b squared equals 1. And then we also know from our slope is always the y, what's under the y value, over what's under the x value. So it's going to be in the format of y equals a over bx. Okay, so that's the format that this slope is in. So let's write an equation for that. We know that a over b is equal to 3 over 2. Well, we also know from the information that they gave us on the vertices are a distance of a. So those vertices are given by this a value right here. So that means that a is equal to 6. So if we know a over b is equal to 3 over 2, and we know that a is equal to 6, there we go, let's plug that in and then we can solve for b. So now we know that 6 over b is equal to 3 over 2. And there's lots of ways that you could solve that, but let's just go ahead and cross multiply and solve and divide both sides by 3. So therefore b is equal to 4. And then that's all we need to be able to write an equation. So we've got y squared over 6 squared minus x squared over 4 squared equals 1. And you can put this in either format, y squared over 36 minus x squared over 16 equals 1. And that works too. Okay, example number 5 is a little bit different here, so let's make sure we look at it. So it says find the standard form of the equation for a hyperbola with vertices at 3, 0 and negative 3, 0. Again, right in between that, center is going to be at 0, 0. And in this case, it's our x values that are changing. So if our x values are the ones that are changing, then that means we're going to start with x squared over a squared this time, minus y squared over b squared. So this is the format that we're going to have for our hyperbola first. So it also means that it's going to be a horizontal hyperbola. It's going to be opening left and right. And that this also gives us that it passes through the point 4, 7. Well, that is an xy point. So we also know a is equal to 3. Okay, so let's write out everything that we know. We know that a equals 3, we know x equals 4, and we know y equals 7. That's going to give us all of this information. Then all we're going to have to do is solve for b squared. So we have 4 squared over 3 squared minus 7 squared over b squared equals 1. And so I'm going to get rid of all my fractions. So let's multiply everything by, I'm going to go ahead and multiply those out. Let's just do that here. So 16 over 9 minus 49 over b squared equals 1. Now let's multiply everything by 9b squared. So that's going to have to be multiplied throughout everything. So the 9's are going to cancel here, and so we'll have 16b squared. And then here the b squareds will cancel, and so we'll have minus 49 times 9. And then that is going to equal, nothing is going to be able to cancel out, so we'll have 1 times 9b squared, which is 9b squared. Okay, so 49 times 9 is 441. So we have 16b squared minus 441 equals 9b squared. So let's subtract 9b squared from both sides, and that's going to give us 7b squared. And then add the 441 to both sides. Divide both sides by 7. 441 divided by 7 is going to be 63. So we'll have b squared is equal to 63. And we could just leave it like that because b squared is what goes into our equation. So we have this form right here. We're going to have x squared over 9. We know that from here. And that we got that 3 from the vertices. Minus y squared over 63 equals 1. Okay, and then that's our final answer. Okay, and then our very last example, we have a problem here. The hyperbola centers at the origin, so 0, 0. Vertices are at 2, 0 and negative 2, 0. So because the x values are changing, then that tells me that this is going to be a horizontal. So, and you can go ahead and graph or plot each one of those points if you need to. But these are going to be opening to the right and to the left, and then the foci is at 4, 0 and negative 4, 0. So everything that's changing is on that x-axis. And they want us to write an equation in standard form. So since we have our x values that are changing, we have x squared over a squared minus y squared over b squared equals 1. And that's the format that we need to fill in. So we know that a, because of our vertices, we know that a is equal to 2. We also know that c is equal to 4 from our foci. So our equation a squared plus b squared equals c squared, because c is actually the longest point in the hyperbolas. So we can fill that in. So 2 squared would be 4 plus b squared. And then 4 squared is going to be 16. So we would end up with b squared equals 12. B equals the square root of 12, but what we really need is b squared, so we'll just leave it there. So we have x squared over a squared, which is going to be 4, minus y squared over 12 equals 1. And that's our final answer.